Uncle Jimmy got life. And Tamika around the corner just took her first hit off the pipe. The other homie shot the other homie and ran off with his money. And when the other homies heard about it, they thought...
Hello, good day. You're welcome to Mathematics Online Tutorial class. I'm Emma, and today we'll be looking at sequences and series. Now, this course will be divided into 3 modules, and we'll treat each module one after the other. Okay. So, my voice is sounding somehow. You just have to manage it. I think my voice is on lockdown, but my brain isn't. And I hope your brain aren't on lockdown also. Alright, let's begin. Now, if you look at your resource file, I mean the PDF that was sent to you, when you look at it, we have the topic that we're treating as sequences and series, and this is module 1. Now, in module 1, we're going to be looking at sequences, and the only sequence we'll be considering in this module is that of the arithmetic progression or the linear sequence. Now, the first thing you need to know is what a sequence is all about. Okay, and if you're looking at your module, you can see that a sequence, any list or set of numbers that follow a fixed pattern, order, or a rule is known as a sequence, and each number in a sequence is called a term. Okay, so if you look at something like this now, if you see something like this now, 2, 4, 6, 8. Okay, this follows a particular pattern because each term is increasing by 2, 2 plus 2, 4, 4 plus 2, 6, and so on and so forth. Now, when you see something like this, it is called what? A sequence. This is called a sequence of numbers, and each number is called a term. So 2 is a term, 4 is a term, 6 is a term, 8 is another term. This is the first term, this is the second term, this is the third term, and this is the fourth term, and so on and so forth. Or we can call this the last term. Now, let's go on. Now, let's look at the following examples, and then we'll get conversant with these things. The first one says we should find the first 4 terms of the sequence and state the general rule each sequence follows. Now, when you look at A, I mean, not solve everything because of our time. Okay, so when we look at A, we have 5, 9, 13, 17, and 21. Of course, when we look at this pattern now, we can see that each successive term increases by a constant number. Okay, and when we inspect it carefully, we see that this constant number is 4. So each term is increasing by a constant number 4. See, 5 plus 4, 9, 9 plus 4, 13, 13 plus 4, 21, and so on and so forth. Okay, so now to get the next 4 terms, okay, I'll only be doing the next 2 terms anyway because of my time. This is the first term. So the first term, we can denote it T1, T subscript 1 as 5, the second term T2 as 9, the third term T3 as 13, and so on and so forth. So what are we looking for now? We have T1, T2, T3, T4, T5. So we're looking for T6, T7, T8, and T9. Okay, so what was the T6? What was T5? T5 is where we stopped. Okay, so T5 is 21. So we have So we have 21 plus 4. So this will be 21 plus 4, giving us 25. And this one will be 25 plus 4, giving you 29. This will be 29 plus 4, giving you 33. 33 plus 4, giving you 37. So the next 4 terms are 25. The next 4 terms are 25, 29, 33, and 37. Now we get that. Now the next thing we have to do is to get the rule. Says state the general rule each sequence follows. Okay, so now what is the general rule? We can see from this sequence that we started with 5. We started with 5 here. And what did we do next? We are adding 4. We were adding 4 to each successive term. Okay, so 5 plus 4. The next one, 5 plus 4 plus 4. So this is T1 was just 5. T2, 5 plus 4. Okay. And sorry. Let me clear all this. Okay. So T1 was 5. T2 was 5 plus 4. T3 was 5 plus 4 plus 4, and so on and so forth. So we can see something. We see that we are adding this constant term to this constant term, this 4. We are adding it to this 5 each time. So we see when we have 5 here, the second term we added 4 to 5 to get 9. The third term we added 4 to 5 plus 4 already from this term, so that we'll be getting 13 and so on and so forth. Okay, so the general term now is giving us what, if we inspect very well, 5 is always constant. 5 is always there, plus then you can see we are adding multiples of 4 each time. In this case, there is no 4. In this case, we have one multiple of 4. In this case, we have 2 multiples of 4. For T4, we'll be having 3 multiples of 4 that we are adding to this 5. So if you factorize here, this is just like 5 plus 4 times nothing. 5 plus 4 times 1. This is like 5 plus 4 times 2. Okay, that's you are factoring these two, you are writing for multiples of itself. Okay, so it means that, and when you watch closely, you see 5 plus 4 times 1, 5 plus 4 times 2. Each multiple of 4 that we are multiplying, each multiple of 4 rather that we are adding to this 5 is 1 less than the term given. Look at this case now. When 4 was nothing, 0 is 1 less than 1. Look at here, when 4, we have just one multiple of 4. 1 is 1 less than 2. Here where we have 2 multiples of 4, 4 and 4 here, it is what? 2 is 1 less than 3. So it means generally, each multiple of 4 that we are going to be multiplying, generally is going to be 1 less than the given term. So now 1 less than this term, n will be what? N minus 1. We're just subtracting 1 from each term. Look at this one. 1 minus 1, 0. 4 times 0. 2 minus 1 in this case. 2 minus 1 here, 1. So 4 times 1. 3 minus 1, 2. So 4 times 2. And so on and so forth. So the nth term now is giving us what? Tn equals what? 5 plus n minus 1 times what? That constant that we are adding each time, 4. So when you multiply through 5 plus 4n minus 4, if you open the bracket up, giving you what? 5 plus, giving you what? 5 minus 4, 1 plus 4n. So this is the general term for that sequence. Okay, now for the other ones I won't write, I will just do some bit of explanations, and I hope you guys will be able to get it then. Okay, when we look at the second sequence, 21, 31, 26, 21, 16, each of them is decreasing. Now, look at the first sequence was increasing each time. 5, 9, 13. So that one, you know that you are going to be adding a constant term. Now, when a sequence is decreasing, you should know that you are going to be subtracting or dividing by a constant term. So in this case now, 31, 26, 21, if we inspect very well, this term is decreasing by 5. It's decreasing by 5. By yourself, you can find the general rule for that. This one, for C, each term here what happens to each term here? It's increasing, and it is increasing in multiples of 3. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and so on and so forth. Let's look at D. What is happening with D? D is also increasing, and it's increasing by multiplying 2 by each term. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, and so on and so forth. E, what is happening with E? E is decreasing, but it is decreasing by division, okay, by dividing by 2. 32 divided by 2 is 16, 16 divided by 2 is 8, 8 divided by 2 is 4, and so on and so forth, okay. So as we can see now, all of these sequences that we've considered from A to E, they all follow a pattern. They follow a consistent pattern. Either they are increasing by a constant number, or they are decreasing by a constant number. That is why, or that is where the term sequence comes from. If you look at definition again, any list or set of numbers that follow a fixed pattern, order, or a rule is known as a sequence. So you see that every of this term here, every of the sequence, or all the set of numbers that we've considered so far, they follow a particular pattern. Okay, that's that about that. Okay, now let's look at linear sequence. Now there are types of sequences that we have. We can either have the linear sequence or the exponential sequence. Okay, so now let's consider the linear sequences. Linear sequence, another name for a linear sequence is the arithmetical progression. Now, what is a linear sequence? A linear sequence is a sequence in which the consecutive terms increase or decrease by adding or subtracting a constant number. This constant number is known as the common difference, and it is denoted D. So when you see a sequence that is increasing or decreasing by addition or subtraction, or let me put it this way, when you see a sequence that is increasing or decreasing, and the pattern by which it is increasing or decreasing is gotten by either adding a constant number or subtracting this constant number, then you know that sequence is what? Is a linear sequence. Look at, for example, now, when you consider the sequences we consider, the sequences we look at in number 1, when we had 5, 9, 13, 17, 21, it was increasing. And how was it increasing? By the addition of a constant number 5. That 5 there is known as the common difference. Constant number 4. 4 is the common difference. When you look at B, 31, 26, 21, this is also what? A linear sequence, because it is increasing or decreasing by the by the subtraction of a number. But C is increasing, but not by addition or subtraction of a constant number. It is increasing by multiplication. Likewise, D is increasing by multiplication, and E is what? Decreasing by division. So C, D, and E are not linear sequences. Just A and B are linear sequences. All right. Now let's move on. Now, what is the common difference D of a linear sequence? Now, you need to know what the common difference is of any linear sequence. What the common difference is. Okay. The common difference D, just as it has been given to you there. D. Let me separate this. Okay. Should I? Okay. Let me just trash that page away, and let's start on a fresh page now. Okay. Now well, looking at the common difference D of a linear sequence, the common difference D is given as what? D is equal to Tn minus T subscript n minus 1. Okay, Tn here indicates any given term, a particular term of interest, and Tn minus 1 is the term that precedes this particular term of interest. Okay, so for example, T1, okay. Let's just leave that. Okay. Now let's look for the common difference in each of the following linear sequences. I will only do one. You guys should know what to do. I will explain that one very well. Okay. In 2a, we have 7, 11, 15, and 19. Okay, so what is the common difference in this case? The common difference is just gotten by subtraction of successive terms. So 11 minus 7 should give you a D. 15 minus 11 should give you the same D. 19 minus 15 should also give you the same D. In other words, D should be constant for any two terms that you're subtracting. It's this way: 11 minus 7, not 7 minus 11. Then 15 minus 11, not 11 minus 15, or 15 minus 7. No. Then 19 minus 15. Any of these ways you get the same thing. 11 minus 7 is 4. This is also 4. This is also 4. Please take note that it is Tn minus 1. We are subtracting a term from the term that immediately precedes it. Not 19 minus 11, not 19 minus 7. It's either 19 minus 15 or 15 minus 11 or 11 minus 7. Not 7 minus 19. Please take note about that. For any linear progression in this world, that's how you get the common difference. Okay, I'm trying to rush now. Now let's go to the next part, the nth term of a linear sequence. Now, how do you find the nth term of a linear sequence? The nth term is just talking about any given term of interest. Okay, the nth term, denoted T subscript n, is given as what? A plus n minus 1 D. So like I said, this one now represents any term of interest. T2 could be your nth term, T4 could be your nth term, T100 could be your nth term, whatever, just depending on the term of interest. And A is known as the first term. It's already there. I think it's there in your booklet already. A is known as the first term. You can see it. A is the first term, okay? N here is the number of terms in the sequence. D is the common difference, okay? That's that about that. Now let's get to solving ways. Let's solve. Number 3a. Find the 4th, 10th, 40th, and nth term of the linear sequence 6, 11, 16, and 21. Okay. So now to get that, 3a. So we are given 6, 11, 16, and 21. Okay, we want to find the 4th term and blah blah blah. So what you just do is use the formula Tn equals A plus n minus 1 D. Okay, so now in this case, now the Tn of interest is T4. So the 4th term now, that will be what? A plus n. How many terms now? 4 terms. 4 minus 1, then D. The next thing is to get your common difference. How do you get your common difference? 11 minus 6, 16 minus 11, 21 minus 16, any one. Let me just use 11 minus 6, 5. So D is equal to 5. And then what is your A? A is the first term, the term that occurs first in the sequence, that is 6. Input this into the formula. We have T4 to be equal to what? What is T4? T4 to be equal to 6 plus 4 minus 1, 3 times D. So that's 6 plus 3 times, what's that, D? 5, giving me what? 6 plus 15 equal to what? 21. Okay, so the 4th term is 21. If you solve on your own, the 10th term, that's A plus 9D, that will be equal to 6 plus 45, 51. And the 40th term, T40 is giving us what? A plus 39D, okay, giving you what? 6 plus 195, giving you 201. Okay, now to find the nth term of that sequence, the nth term of the sequence, okay, recall the nth term is giving us what? A plus n minus 1 D. Okay, so the nth term now will be what? 6. A is 6. Nth term, I don't know. N minus 1 times our d is giving us 5. Okay, so when you expand this, you have 6n minus 6n minus 5n minus 5, giving you what? What am I doing? Sorry. The formula I used here was wrong. Okay, so this should give you what? 6 plus 5n minus 5, giving you what? 1 plus 5n. Okay, so that's that about that. We are done with number 1. Now, number 2. Find the 7th term of an AP whose 4th term is 5 and common difference is -2. Okay, so for the B part, we want to find T7. Okay, we are giving T4 as 5 and D as -2. Okay, so I think to find any term in any sequence, the formula is given as a plus n minus 1d. Okay, so since we know d, our next interest now is just to get our a. Once we know a, we are good to go. Okay, now T4 is equal to what? A plus 3d, and we're given that T4 is what? Is 5. So it means that what? A plus 3d is equal to 5. And recall also that d is equal to what? -2. So substitute -2 here. We have what? A plus 3 times -2 equal to 5. So now we're going to be solving for a. So in other words, a is just going to give me what? -1. Okay, this times this is what? -6. It's -1, sorry. A will give me 11. Okay, so what is my T7 now? So T7 now will be equal to what? A plus 6D. A plus 6D. So if you don't know how, let me just explain this. All this my T4, I say A plus 3D. I said T4 equals A plus 3D. These are terms that you get used to as you solve the more. T4 is A plus N. Sorry. A plus N is what? 4 minus 1D. Okay, if you are using the nth term, A plus N minus 1D. So T4 now, A plus N is 4. Tn. N is 4. So 4 minus 1D, giving you what? A plus 3 minus 4 minus 1, 3D. Okay, and if you remember what I was explaining the other time from the beginning of the whole work when I was here, I said that for each term given, the multiples of the common difference is always 1 less than the given term. So in this case now, we have multiple of 4 twice. It is 1 less than the term T3. It's what follows even to this aspect. Okay, so when we're having, any term will just be any term's common difference will be 1 less than the given term. So in this case now, when we have T4, our formula will just be A plus 3D. 1 less than this. The multiples of the common difference 1 less than this T4. If it was T90, that would be what? A plus 89D. If we had T100, that would be what? A plus 99D. Simple way of writing the formula instead of writing all this long form. Okay, I just wanted to explain that. Okay, so from where we stop now, T7 will be equal to what? A plus 6D, and our A was giving us what? 11 plus 6 times -2. -2 is our common difference, giving you what? -1. So that's the 7th term. That's that about that. Next, I might have to skip some because of our time. Okay, what is the first term? Sorry. What is the first term of the AP in which the common difference is 6 and the 8th term is 17? The common difference is 6 and the 8th term is 17. Okay, I may have to skip some of these things that look like repetitions already. What is the first term of an AP Okay, to find A, given that T subscript 8 is equal to 17 and D is equal to 6. T subscript 8, that's T8 is what? A plus 7D, and D is equal to 6. Don't forget that the 8th term is 17. It means that what? A plus 7D, this 8th term is what? 17. Now substitute the value of D inside this equation so that we'll be solving for A. Then we have what? 17 is equal to what? A plus 7 times 6. So 17 is equal to what? A plus 42. So what is A? A is equal to what? Negative 25. So the first term is negative 25. So these are you solve questions like this. Okay, if you have a very good basic understanding about this, when we get to more complex exercises, it will become easy for you. Okay, let's look at this. The 7th term of an AP is 22 and the 30th term is 91. Find the 50th term and find the nth term. Okay. D. The 7th term of an AP is that. So given T7 is equal to what? 22 and T30 is equal to what? 91. 7th term is 22, 30th term is 91. We want to find T50. Okay, before we can get our T50, we need to know our A and our D. Anytime you are solving to get any nth term of any linear sequence, you should know your A and you should know your D so that you can substitute into the formula. So in this case now, we can get our D by rewriting this to T7 is what? A plus 6D, and that's equal to 22. And then T30 is equal to what? A plus 29D. This is equal to what? 91. Call this equation 1. Call this equation 2. Now you're going to solve these two equations simultaneously. Whenever you see two unknowns, a system of two unknowns in two equations, you know it's a simultaneous equation. The two unknowns here are what? A and D. And then you see it in two equations, equation 1 and equation 2. So solve simultaneously. If you solve simultaneously, you have A equal to 4 and D equal to 3. Okay, so if A is equal to 4 and D equals to 3, then it implies that what? T50 is equal to what? A plus 49D. Okay, A is what? 4 plus 49 times what's our D? 3. Giving you what? 151. So the 50th term is 151. To get the nth term, Roman figure 2. The nth term, Tn equals what? A plus n minus 1d, which is what? This implies 4 plus n minus 1 times 3, which is what? 4 plus 3n minus 3, which is what? 1 plus 3n. Okay, so these are just the basic ways of solving anything that concerns linear sequences. I want to believe that at the end of this tutorial, for those of you that have not mastered it before, you should be excellent solvers of this particular topic. It's no more than this. Okay. E. Determine the number of terms, which is 83 in the AP. So, okay, look at this. Number E, we are given a particular AP, given a particular AP 3, 8, 13, and 18. Okay, and then they now asked you to determine, to find which of this term, when n is equal to 83, which of the term inside this sequence is going to be 83. Is it the first term? Definitely can be the first term. The first term is 3. Is it the 20th term? Is it the 14th term? Is it the 100th term? Which term does it occur? Okay, now you're going to substitute into the formula and you're going to be solving for n. N is what you're solving for in this case. So Tn now, recall the formula. The Tn is what? A plus n minus 1 d. Now, this term should give us 83. Okay, what is the first term? A is 3. Plus n minus 1. Then what is the common difference? If you look at this, the common difference is 5 times 5. Okay, so let me explain this now. This one is saying which term of this sequence will be such that when this operation is performed, the Tn I'm going to be getting will be 83. The nth term of this, which number, which term will make the nth term of this sequence 83? So we're looking for that term, which is n here. So let's check it out. So we have 83 equals what? 3 plus n minus 1 times 5. So 83 is equal to what? 3 plus 5n minus 5. N equals what? 17. So what does it mean? It means, so n is equal to 17. So it means 83 is the what? 17th term of this sequence. Is the 17th term of this sequence. If you want to check it out, then we may now try and check it just to confirm. So it means T17 is what should give us 83. Let's check it out. T17 is what? A plus 16D, which is equal to what? What is our A? Recall our A is giving us what? 3 from the question. A is 3 plus what? 16 times, what is D? 5. That's 3 plus 80, giving you what? 83. So it is the 17th term that gives us what? 83. So in this sequence, when you look at it, this sequence, it is the 17th term inside the sequence that gives us 83. I think we understand the concept now. So let's move to F. In an AP, the difference between the 8th and the 4th term is 20, and the 8th term is 1.5 times the 4th term. Find the common difference. Okay, so in an AP, so given in an AP, the difference between the 8th and the 4th term is 20. Given difference between the 8th and 4th term, T8 minus T4 is equal to 20. Difference between 8th and 4th term is 20. 8th term is 1.5 times the 4th term. This 8th term here is what? 1.5 times of what? Of this 4th term. So what are we to do? Find the common difference and the first term of the sequence. Okay, so to find it, now this is the first statement and this is the second statement. Okay, T8 is what? A plus 7D, and T4 is equal to what? A plus 3D. From statement 1. 8th term minus 4th term is 20. So it means A plus 7D minus A plus 3D will give me 20. Notice I put bracket after this my negative sign because negative will affect everything. So you're saying the 8th term minus the whole of, if you didn't put bracket now, this negative will not affect this plus 3D. Okay, and your answer will have issues. So when we solve, we have A plus 7D minus A minus 3D equals to 20. Okay, so A cancels here, 7D minus 3D, that's 4D equals 20. So it means that what? D is equal to 5. So the common difference is 5. We've answered the first question. And the second question says we should do what? Where is it? Find the first term of the sequence. So we want to find A now. Roman figure 2 to find A. What is A? Okay, from statement 2. From statement 2. What was statement 2? C8 is equal to, the 8th term is 1.5 times the 4th term. 8th term is 1.5 is equal to times the 4th term. So it means A plus 7D is equal to what? 3 over 2 times of what? A plus 3D. Okay, recall, don't forget your D is equal to 5. That's what we just got now. So you're going to substitute 5 into this equation. So we have A plus 7 times 5, D is 5, equals what? 3 over 2 into bracket A plus 3 times 5. Okay, because D is 5. Then you have what? A plus 35. Let me put this in bracket. A plus 35 is equal to what? 3 over 2 into what? A plus 15. Okay. So then we will have something like this. A plus 35 equals what? 3A. I'm expanding this bracket here. 3A plus 45, everything over 2. Cross multiply. You have 2 open brackets. A plus 35 equals what? 3A plus 45. So therefore we have 2A plus 70 equals what? 3A plus 45. What does this imply? It implies that what? You bring this here, bring that here. 3A minus 2A equals what? 70 minus 45. Implies that A equals to 15. So it means for that particular sequence, the first term is 15 and the common difference is 5. We are done with that. And let's look at G. The 8th term of an arithmetic progression is 5 times the 3rd term, while the 7th time is 9 greater than the 4th term. Write the first 3 terms of the AP. Okay. Now let's look at G. The 8th term of an arithmetic progression is 5 times. Let's write this down. So T8, the 8th term is what? 5 times the what? The 3rd term. So it's 5 times of T3. While the 7th term, what's the 7th term? T4. Sorry. T7 is 9 greater than the 4th term. Is 9 greater than the 4th. Okay, 9 greater than the 4th term. That's T7 minus 9 equals T4. Or you could say T4 plus 9 equals T7. That's the interpretation of statement 2. This statement 1 and this statement 2. Now let me explain the second statement in case you didn't understand what was going on here. Now say for example, Fumito has a junior sister. Her name is Funbi. Okay. Funbi is, let's have Fumito. Fumito is 14 years. Funmito, okay, it's like they like the F initials in their home. Funmito is 14 years old, and Funbi is, now look at the statement. If Fumito is 9 years older than Funbi, then it means Funbi is how old? Funbi will be 14 minus 9 years old, meaning she's 5. So Fumito is what? 9 years older than her, making Fumito 14, and she is this. Now, if you wanted to express this in an equation, well, let's use F1 for Fumito and F2 for Funbi. Funbi. I really like F in their home. Let's go on. Now, Fumito expressing this in this term now, it means that for them to have equal ages, for F1 to be equal to F2, you have to add what? 9. So this is Fumito now. This is Fumbi. Before they can be equal, before you know equality, when you are talking of equality in mathematics, it means what is on the left is equal to what is on the right. So if you're expressing in terms of this, it means that Fumito is what? If this is Fumito F1, then Fumbi is what? F2 plus 9, for them to be 14, 14. Or you say F1 minus 9 is equal to what? F2. Because you know F2 is 5 and this one is 14. So 14 minus 9 will give you what? 5. So 5 should be equal to 5 here. Or you say 14 equal to what? 5 plus 9 give you 14, 14. So you express it in any of these two terms. So that's what I meant when I wrote this. When we were told that the what? Where is the question again? The seventh term is 9 greater than the fourth term. This seventh term is 9 greater than this one. Is 9 plus this one. So it's either you write it this way or you write it this way. Okay? So maybe let's stick with this. Let's stick with the second statement. So let me rub off the rest. Okay. I'll stick with this. The seventh term is what? 9 more than the fourth term. This one is 9 more than this one. Okay? Good. So it means that if this one was 20, then this one will be 13. For them to now be equal, you have to add 9. Sorry, this one was 11. So for them to be equal, 11 plus 9, you will now have 20 here, equal to 20 here. I think that's that for that. If you still don't understand it, you can ask your friends and they'll tell you better. Okay, now let's move on. That one has taken much of our time already. Okay, so this is statement 2. Alright? So from statement 1 now, if we simplify from statement 1, T8 is A plus 7D. That's what? 5 times. What's T3? A plus 2D. Simplify. A plus 7D equals what? 5A plus 10D. If you bring them together, you have what? 4A plus 3D equals to 0 from statement 1. From statement 2, look at statement 2. T7 equals T4 plus 9. T7. Let's get rid of this. T7 is that's the seventh term. A plus 6D is equal to what? T7, T4 plus 9. That's A plus 3D plus 9. Okay? So when you solve, you have what? A plus 6D equals A plus 3D plus 9. Bring together 2D equals what? Sorry? A will cancel A here. So you have 6D minus 3D. 3D equals to 9. Then D is equal to what? 3. Okay. So you can see D is equal to 3. What are we even told to get? Write the first 3 terms of the AP. Okay, so D is equal to 3. Now, if D is equal to 3, substitute for D equals 3 in equation 1. So we have 4A plus what? What's our equation? We wrote this equation here. 4A plus 3D equals to 0. So 4A plus 3, what is D? Equals to 0. So we have 4A plus 9 equals to 0. So it means A is equal to what? Negative 2 number 1 over 4. So what are the first 3 terms? The first term is what? Negative 2 number 1 over 4, and then the first one minus 2 over number 1 over 4. Second one is 3 over 4. That should just be adding 3 to each term, and the third one will be what? 3 over 4. So these are the first 3 terms of the sequence. Let's move forward. How many numbers each? How many numbers between 75 and 500 are divisible by 7? Okay. How many numbers between 5 and 75 that are divisible by 7? Now let's look at it. The first number that can be from this 75, this is the boundary. We have 75 to 500. Now, if we start from 75, see, we know that 75 is not exactly divisible by 7. The first number from this digit that can be divided by 7 without a remainder is 77. Okay? And the last number also that can be divided from this 500, 500 is the last number in the boundary. The last number that is exactly divisible by 7 is 497. Okay, because 498 can go, 499 cannot go, 500 cannot go. Okay, so we have 77 and 497. In other words, this 77 is your first term that can be divided by 7 in the boundary, and this is the last term that can be divided by that number in the boundary. Okay, last term, Tn. So how do we recall that Tn is equal to what? A plus n minus 1d. Okay, what is Tn? The last term that can be divided by this is what? 497. So 497 is equal to what? First term, A 77 plus n minus 1 times, what's the common difference? The common difference is 7. Okay, because multiplication or multiples of numbers is repeated addition. If you look at this 77, that's the first place where we see a factor of 7. The next number that will be a factor of 77 will be what? That will be 77 plus 7, which is what? 84. 84. The next one will be what? 84 plus 7, which is equal to what? 91. The next one will be what? 98, and so on and so forth. So when you look at the common difference, it's all 7, 7, 7. So the common difference is 7. So we want to, the question asks us to find the number of terms. How many numbers? So is this n the number of terms that will be in between this division? Okay. So how many numbers can we see inside this? So we have to solve for n now. So when you open your bracket, you have 497 equals what? 77 plus 7n minus 7. So 427 is equal to what? 7n. N is equal to 61. So it means that there are 61 terms between. There are 61 terms between what? 75 and 500 that are exactly divisible by 7. Okay. If 8, so giving 8, x, y, z, and 20, there are terms in an AP. We want to find x, y, and z. Okay, now this one is quite similar to something we've done before. 8 is the first term. This T1. First term, this is the second term, T2, this is the third term, T3, this is the fourth term, T4, and T20 is what? The fifth term, or the last term in this sequence, T5, the fifth term, and is also the last term in the sequence. Okay, so A, the first term, is what? 8. T5 is 20. But T5 is what? A plus 4D. So it means A plus 4D is equal to what? 20. And our A is 8, so substitute. So we have 8 plus 4D equals to 20. It implies that what? D is equal to So the common difference is 3. Once you know your A and you know your D, you can get any term in any sequence. So now to find X. X now, you know X is what? The T2. Y is T3 and Z is T4. So X T2, that's what? A plus D or A plus 1D. 1 less than 2 term, which is what? 8 plus 3, giving you 11. Giving me 11. Y T3 Z T4. A plus 2D, A plus 3D. So A plus 2D now, that's what? 8 plus 6, giving you 14. This 8 plus 9, giving you 17. So X is 11. Y is 14. And Z is 17. Okay, so that's that about that. J. Find the value of X given that X plus 1, 2X, and 2X plus 3 are consecutive terms of a linear sequence. So how do we do this? Okay, like I said, once you know A and you know D, you're good to go. But okay, we're not even looking for the nth term in this case. We're just to find X. How do you find X? There's a clue you can use. These things are in arithmetical progression, so that means we have something like this. For you to be able to find X, you have to solve an equation in X, okay? I know that the common difference D is giving us 2X minus X plus 1. This term minus this term. And it is also the same thing as what? 2X minus 3 minus 2X. This term minus this term. Okay, you use it to get your D. Now let's equate, and you know that this is always constant. If this one minus this one gives me 5, it means this one minus this one will also give me 5. That's why I'm equating them to each other. And you know that 5 is equal to 5. Okay, so these are you solve questions like this. If you see any question like this, these are you should always solve it. Do 2 subtractions and equate them together, because D is a constant term. The common difference is always constant and it must be equal to each other. So 2x minus x minus 1 is equal to what? 2x minus 2x. This one cancels here. So I have what? Negative 3 here. Okay? Sorry, this is 2x plus 3, not 2x minus 3. 2x plus 3. So this is positive 3. Sorry about that. Okay? So 2x minus x, that we have x minus 1 equals to 3. So x is equal to what? 4. So x is 4. That's that about that. Let's move to K. The first term of an arithmetic progression is negative 8. Okay, so we are given that A is equal to what? Negative 8. First term of an arithmetic progression is negative 8. The ratio of the 7th term to the 9th term is 5 to 8. Ratio of 7th term, that's T7 divided by T8, is what? The ratio of 7th term to the 9th term, 9th term is T9. Is what? 7th term to the 9th term. Where's the question? 7th term to the 9th term is 5:8. So 5 over 8. Calculate the common difference of the progression to find T. Okay. Now T7. What is T7? That's A plus 8D. Sorry. How am I doing this? A plus 6D, and T9 is what? A plus 8D. This is what? 5 over 8. Okay, now recall the first term of the arithmetic progression is what? Negative 8. So you are going to substitute that inside this. So we have negative 8 plus 6D divided by what? Negative 8 plus 8D equals what? 5 over 8. So you cross multiply, you have 8 open bracket negative 8 plus 6D equals 5 open bracket negative 8 plus 8D. Okay, so this gives you what? negative 64 plus 48d equals negative 40 plus 40d. Okay, 48d minus 40d equals what? 64 minus 40. So 8d equals 24. Then d is equal to what? 3. Okay, so the common difference of the progression, d is equal to 3. Sorry if I'm speeding. I'm doing that because of time. And if you don't understand how the equations are working, then you need to go and strengthen your equation solving. Like the simultaneous equations, I'm not solving them, I just work them directly. Okay, so please go and strengthen your equations. If you know they are not strong enough, your linear equations, both one linear and the simultaneous equation also, please go and make sure you strengthen them so that you get the full depth of this tutorial. This tutorial is just for sequences and series. I'm not really teaching about equations, so but if you have a basic understanding of equations, you will know how all these things are gotten. Okay, so that's that about that. Let's look at L. The first and last terms of two arithmetic progressions are the same. The first and last terms of two arithmetic progressions are the same. Okay, so let's call the first AP. Let it be Tn subscript 1. The first one equals what? A1 plus N1 minus N minus 1D. I'm using this one to indicate that this is the first AP. Then the second one, Tn2 equals what? A2 plus N2 minus 1D2. Okay, so that we will know that there's a difference between the two progressions. Now, from the question, the first and the last two terms of an arithmetic progression are the same. The first, here it is, the first and last terms. So it means Tn1 is equal to Tn2 from the question. And also, sorry about that. And also, the first and the last terms, A1 is equal to A2. This is the first term of the first sequence. This is the first term of the second sequence. This one is equal to this one. And then the last terms also Tn1 and Tn2. They are equal to each other from the question. Let's move on. The first AP has 51 terms with a common difference of 6. So this first one has 51 terms. So Tn1 is equal to A1 plus N of this one is what? 51. With common difference of what? 6. So if you put that into this now, you have what? 51 minus 1 multiplied by what? Multiplied by 6. Let's look for any clue for the second term. Find the number of terms of the second AP if its common difference is given as 4. So this one, the common difference is given as 4. We want to look for this, the number of terms in the second. So Tn2 equals what? A2 plus N2 minus 1 times 4. Because we are given that this. Okay, so how do we solve something like this? This is 1, this is 2. From equation 1, Tn1 is equal to what? A1 plus, expand this bracket, you have what? 51, 50 times 6, that's 300. So this is Tn1. Okay? But recall that Tn1 is equal to Tn2. So this nth term, the last term, this is the nth term of this sequence. It is also equal to this nth term of this sequence, the last term. The last term is equal to this last term. So Tn1, since Tn1 is equal to Tn2, so we'll be having what? I can replace this Tn2 with Tn1 and put what? A1 plus 300 here equals what? A2 plus N2 minus 1 times 4. Okay, so what did I do? I just replaced this last term here with this last term here, and because they are equal to each other, just like saying this one is 6, this one is also 6, so I can always put 6 anywhere since 6 is equal to 6. Also, we're given that the first terms are equal, so it means A2 is equal to A1, A1 is equal to A2. If this is 4, this one is also 4. So let me substitute A2 equal to A1. So I'm going to be having what? A1 plus 300, this Tn2, because it is equal to this Tn1, okay, equals to what? What is A2? A2 is equal to A1. First term and the last terms are equal, plus what? N2 minus 1 times 4. Okay? A1 will cancel A1 here because if it crosses the equation, they will negate each other. So we have 300 equals what? N2, sorry, just expand the bracket once instead of writing stories again. 4 times N2, 4N2 minus 4. Okay, so 304 is equal to what? 4N2. Divide both sides by 4. So N2 equals what? 76. Therefore, this N2 means the number of terms of the second AP. Therefore, the second AP has 76 terms. You can check that out on your own. So, M. Show that 12 is not the term of the arithmetic sequence. 210, blah, blah, blah. Number what? L, is it L or what is it? M. We want to show that, so given 12 is not a term of this sequence, given 210,197,184. Okay, we want to show that 12 is not a term. To show that 12 is not a term. Now, the first thing we need to get is, okay, let me explain the concept of this. How do you show that a number is not a term in the sequence? A number wouldn't be a term of a sequence if 12 was, okay, let's get the common difference first, because if I'm explaining now, it will still be abstract to you if you don't understand what I'm trying to talk about until I solve it. What's the common difference? 197 minus 210. So D is equal to what? Negative 13. And formula for the nth term, Tn is what? A plus n minus 1. D, everybody should know this by now. I've said this like I can count. So now Tn, we want to find the term, the number of terms, the term that gives us 12 in this sequence. Which term will give us 12 in this sequence? Just the way we solved for the other one of 83. That it is the first term, this is the 36th term, it is the 76th term that will give us this. So which term will give us 12 when we solve? Okay, what is A? A is 210. Open bracket, n minus 1 times negative 13. Okay, so 12 equals 210 minus 13 n plus 13. So 13n is equal to what? 211. So 13n is equal to 211. Means that n is equal to what? 16.23. So definitely 12 is not a term, because a term should be a natural number, either 1, 2, 3, 4, 5, 6, 7th term, 8th term, 12th term, not 16.23 term. There's nothing like that. So it's not a term in the sequence at all. Okay, so let's move to n. N, okay, some comets are called periodic comets because they appear regularly in our solar system. Periodically occur. Okay, so now we're looking at the last question. Some comets are called periodic comets because they appear regularly in our solar system. The comet Kojima appears about every 7 years. Okay, so let's look at Kojima. Kojima appears every 7 years. So it's an interval of 7 years. So we can also call that the common difference. So D is what? 7. So every 7 years it occurs. It was last seen in the year 2007. Last seen 2007. All this for Kojima. Okay, let's move on. Halley's Comet appears about every 76 years. Halley's Comet every 76 years. That's the difference, is 76 years interval. The difference between the interval is 76 years. Okay, we can call that the common difference. That's why I'm using D to represent it. And it was last seen in 1986. Last seen in 1986. Determine whether both comets should appear in 3043. So in the year 3043, will both comets occur? Okay, so let's check and see. So we want to project and see if these two comets are going to appear together in the year 3043. So recall Tn is equal to what? A plus n minus 1d. Now this is like the nth term. Sorry, 3043 is like our nth term. It is, in fact, it's even our nth term in this case. So we want to project and see this 3043. Let's work for Kojima. For Kojima, 3043. What is A? Now our A in this case is going to be when it was last seen, the year 2007, when it was last seen. So we're going to be projecting. So that means the next, when it will be next thing will be what? 2014, followed by 2021, and so on and so forth. Okay, so let's use this as our A. 2007 plus n. N in this case now will indicate how many times will it occur before it gets to the year 3043, or how many terms are inside the occurrence between that 2007 and 3043. How many times will it occur? That's if it's even going to occur at all. So n minus 1 multiplied by, what is D? The difference is 7. Okay, so we're going to be solving this. So 3043 equals what? 2007 plus 7n minus 7. Okay, so when you put this together, what do you have? Okay, so we have 3043 minus 2007 plus 7 equals to 7n. Sorry, equals 7n. So 1043 equals 7n. Then n is equal to what? 149. So definitely, since n is a natural number, you can see it's not like the previous example where we solved 12 and where we wanted to solve if 12 was a term and we're getting 16 point something. But now this is a natural number, so it means it's true. It's going to occur in the year 3043, and the interval of times, n, is what? 149 times. So from 2007, 2014 will be the first time, 2021 second time, 2028 the third time, and so on and so forth. Okay, so let's look at, so definitely the comet Kojima is going to occur in 3043. Now let's look for Halley's own, if it's going to be true. Halley in the year this. Okay, for Halley's comet. Okay, Okay, so for Halley's Comet, now if you are wondering what comet is all about, you can check your dictionary or something, but I know there are cosmic terms, things that are like snowballs, snowballs, particles of stars or something like that. That's what they call comets. But you can check your dictionary or Google for better information of comet. And there's actually Halley Comet. Okay. So now, when will Halley Comet occur? If it last occurred in the year 1986, okay, we want to see if it's going to occur in the year 3043, if it's following an interval of 76 years. Okay, so 3043 is also its end term. Okay, that's and then A is 1986 for it, plus n minus 1 D. The D is what? 76 years. So 3043 equals what? 1986 plus 76 n minus 76. So all these 3043 minus 1986 plus 76 equals 76, and this gives me what? 1133 equals what? 76, n is equal to what? N is 14.9079 thereabouts. So since n is not a natural number, it means the comet Halley cannot occur in the year 3043. So they cannot both occur in 3043. Only Kojima is going to appear in the year 3043. Okay, so that's that about that. So this ends the tutorial for module 1. You watch out for the next video tutorial that comes with module 2. And in module 2 we're going to be treating the exponential sequence. We look at the end term of an exponential sequence, and then you watch out for module 3. Module 3, there we're going to be concluding the whole sequence and series chapter. In module 3 we're going to be talking about series, and we'll talk about everything that we need to know about series, and then we end everything for sequences and series. Then we'll move to another topic. Thanks for watching and listening.